Good afternoon, everyone. My name is John Austin. I am the Lands and Habitat Program Director with the Vermont Fish and Wildlife Department. I appreciate the opportunity to speak with you today on the topic of what we know regarding the effects of sound and noise on wildlife. With me today is my colleague Scott Darling, the Wildlife Management Program Director. I thought what I would do is start with building a little bit of context around how the Agency of Natural Resources has considered the effects of wind energy development on wildlife broadly, and then work into the topic of the discrete issue of sound, or the effect of sound and noise on wildlife behavior. So the Vermont Fish and Wildlife Department exists to represent the public's interests in the conservation of fish and wildlife for the great state of Vermont. And one of the ways that we represent that interest is in working to protect habitat for all the species of plants and animals in the state through all the various regulatory mechanisms. And so what we do in the case of reviewing energy projects is provide what we view as objective science-based technical guidance to institutions like the Vermont Public Service Board to help guide their decision-making and hopefully make the right decisions regarding impacts to the Vermont's environment. Could I have slide 2, please? So, from the larger perspective, what are our concerns regarding energy development in Vermont, or wind energy development in particular, with respect to wildlife? Well, there are many, and some of them are obvious. It's the direct loss of important habitat that our wildlife require in order to live and survive in the state. It's the fragmentation or parcelization of the habitat, that is, breaking the habitat components into smaller and smaller pieces, which has all sorts of attendant effects on plants and animals. It deals with how animals are able to move across the landscape and access important habitats to feed, find mates, and ensure the genetic viability of their populations. Associated with both of those things is the degree to which our presence, our activities result in disturbance and displacement effects to animals. And that varies depending on the species that you're considering. Some are more accommodating of our presence than are others. And then, of course, there's the direct mortality of animals. And that may be from vehicles driving down the road, or birds and bats colliding with wind turbines, or fish passing through hydro facilities. Next slide, please. This is slide 3, by the way. So our concern from the big picture is really the combination of all of these effects. And I'll be honest with you, the science and our understanding of all of this is growing and emerging as we deal with these issues, these challenging issues, because the effect on the environment and the ecosystem it's complicated. I mean, these animals and how they relate to the environment and what they need, how they behave, is very complex. And even though we've been studying wildlife for many decades, we still have a lot to learn. So we're constantly mindful of that, and the agency's approach in dealing with these issues is to take a cautious approach and try to assume a certain degree of effect based on the science that we have. Could I have the next slide, please? This is slide number 4. So let's get into the specific issue on sound or noise on wildlife. There's really a lot that we do not know. This is very unlike how we deal with the effects of sound on ourselves. We can't ask these animals how they feel about a stimulus that's out there. And again, their behavior is complex, and what they're doing is trying to survive and reproduce and find food every day. That's what they do. And they're confronted with all sorts of olfactory, and visual, and auditory stimuli in the environment. So in many instances, it's how all of these factors work in concert with one another that is what likely drives their decision-making and their behavior. So the point is, it's hard to isolate the effects of sound specifically on animal behavior. But I'm going to share with you shortly some of the science that does try to get at that issue. So again, we're still learning. We've got further to go. It is a difficult thing to measure because, again, what you're dealing with is trying to understand the behavioral response of an animal to what you're assuming is related to the effect of sound. Maybe, a whole amalgam of effects out there. So what happens when you have noise effects on animals? And again, it may be in concert with some other effects. Well, it can change their use and access to habitats. So if an animal is disturbed by a noise or other factors, they may elect to not use otherwise suitable habitat. Or they may elect to use it during the time periods when the sound is not present. It can increase stress levels. So there's been a variety of studies that have looked at stress hormone levels in the bloodstreams of wild animals, and you can find a correlation between disturbance, stimuli, and stress levels. You get heart rates, for instance. And then, the consequences of some of this are it ultimately can affect reproductive success, which can affect your ability to deal with wildlife conservation at the population level, which ultimately is what we're really concerned about. And it can interrupt social communication because, keep in mind, think about birds, for instance, the over 150 species of birds that we enjoy in the great state of Vermont. That is a very vocal animal. They communicate every day using sound. And there's a lot we don't know about the intricacies of how they vocalize and how they interpret that social information. And so how or to what extent other sound in the environment can affect their ability to communicate effectively it is something that we still have a lot to learn about. The next slide, please. So from a very general point of view, here are some of the ways that wildlife can respond to sound or noise. One is the disturbance effect, which I already just alluded to. Here is where the animal just decides to avoid or leave an area because of the disturbance. And the picture at the top is a picture of an American bittern. It's a marsh bird. They're not terribly common, and they tend to be they're a wading bird, kind of like a heron. They're solitary individuals, and they are very intolerant of human disturbance. And we're not sure whether it's the sound or just our mere presence, what it is, but if people are there and there's a disturbance effect on bittern using what is typically their nesting habitat in the marshes, they leave the area and oftentimes don't come back. They're very, very sensitive to that. On the other hand, you have raccoons, which have adapted to become very accommodating of human presence and activities, and in fact, actually exploit the environmental conditions that are generated around our activities. There's animals that will habituate and acclimate, like the raccoon. You could have temporal effects, so it could be that an animal decides to use an area of habitat that's important to them at night, perhaps when the sound or the disturbance factor isn't present or lower in the environment. And then you can have the tolerance effect, and this is the tricky one, because in many cases you might see a bear, a deer, a moose present in an area where there is a disturbance or the presence of people, and you might assume that there's no effect. But in fact, what they're doing is there's sort of a cost-benefit ratio going on here. It's we see this with deer in the wintertime, for instance, where they may or they may not flee from snowmobile traffic. But what we found through earlier scientific investigations is that they experienced stress through the release of stress hormones in the bloodstream and increased heart rate. And in the wintertime for deer, that's a bad thing. They're trying to survive the wintertime through energy conservation. That's what makes or breaks deer in this part of their environment. And so even though you see them and they're not running away from the snowmobiles, there's an effect that's happening there that could ultimately affect their overwinter survival. So they're choosing to tolerate the disturbance because they need that habitat in order to survive. A colleague of mine yesterday made the analogy that it's kind of like us electing to drive into New York City every day to go to work. Of course, none of us presumably are. But I guess, you know, the cost-benefit factor there is you drive into the city and you deal with all of the stress and hassle of that because you can make a bunch of money. I tried to come up with a better analogy related to my marriage, and I couldn't. She just tolerates them. The next slide, please.
And chooses not to move on.
Apologies. So let me share with you a few of the studies that we examined recently to aid this conversation regarding the effects of noise on wildlife. I've got several of them. I'll run through them. So there was a study conducted in the boreal forests of Alberta, Canada, and this one is interesting because it was looking at a species of bird called the ovenbird. It's a common forest interior warbler that we have in Vermont. And in this study, what they were looking at were the effects of chronic noise from natural gas drilling facilities. And what they tried to do, the interesting part of this study, was they tried to account for all of the other landscape variables that could influence the bird's mating behavior, and tried to isolate the effect of the sound of the natural gas drilling activities. And the way they did that was they took several sites, all of similar character. They were all disturbed sites. They had natural gas drilling infrastructure on them, but they also supported habitat where this bird occurred. And some of the sites were active and some of them were not. And so the active sites, of course, had the sounds and whatnot associated with the drilling activities, and the control sites did not have the sound. And what they found was that in the sites that had the sound, that there was a significant reduction in the parent success and age distribution of the male ovenbirds. What this means is that the older male ovenbirds were electing to not occupy the areas close to the areas with the sound disturbance. They were moving much further away. Where in the areas, the control sites, this difference didn't occur. The older males stayed with the females and stayed paired. The reason this is important is that the younger males are in theory less fit. They don't tend to stay with the adult female long enough to ensure successful reproduction, and ultimately it could have an effect on reproductive success. The next slide, please. Another study looked at the effects on natural gas drilling on greater sage grouse. This is a species of galliform grouse that's actually in precipitous decline these days out in the western United States, and it's a candidate for federal listing on the endangered species list. In any event, they looked at the effects of noise and disturbance associated with the natural gas drilling facilities, and found that in many instances these birds simply avoided otherwise suitable habitat. So habitat that could have been used, occupied by these individuals, simply wasn't, attributing it to the disturbance effects of the natural gas drilling. And then they looked at, through analyzing hormone levels in their droppings, they were able to demonstrate that there were increased stress levels because of higher cortisol levels in the bloodstream for those individuals that were in close proximity to these operations. The next slide, please. Another study out west looked at effects on traffic, logging truck traffic, on species of raptor, the northern goshawk. This is also a species of bird that occurs in Vermont. And this one was looking at whether or not the traffic disturbance was having an effect on their reproductive success. And in general, they found that, in fact, it was not. The birds were the birds that were closer to the roads where this truck traffic occurred spent more time exhibiting vigilant behavior. That is, their head was up, they're looking around, they're looking to understand what's going on and see if there are any threats. But overall, it didn't affect their reproductive success. Next slide. The American kestrel. This is another, the smallest raptor that we have in North America. It occurs here in Vermont as well, although this study was conducted in Idaho. This study looked at, again, the effects of traffic sound on nesting success of American kestrels. American kestrels are cavity nesters, so they nest in holes in trees, kind of like a wood duck. And what this study found was that the traffic noise, so pairs of kestrels that were nesting closer to roads had a 10 times higher chance of nest failure than those nesting further away from the roads. And the thought here was that because this species cannot combine, say, visual cues with auditory cues, that perhaps those that auditory stress level not being buffered by the ability to see what's going on around you, was part of the reason for abandoning these nests. But in any event, it did have a significant effect on the reproductive success the closer you were to the sound associated with the roads. Next slide, please. Another study conducted out in the Grand Teton National Park, looking at behavior of elk and pronghorn antelope. This investigation found no significant change in behavior for these animals, regardless of how close they were to the road that goes through the national park, or, that's what they found. There were some interesting aspects of this, though. One is, and this is true for deer in Vermont, for instance, is these animals may acclimate to some of these predictable stimuli in the environment. So these animals are dealing with traffic at a steady pace along a main road through a national park fairly regularly every day. But when that traffic level was lower and you had an unanticipated event like a motorcycle or a pedestrian come by, these animals were on high alert and they moved away from the road. So again, this is the sort of thing that, in my view, it is illustrative of how complex their behavior is to all these different stress factors in the environment. The other fact is that this road through the national park has been in existence for a very long time. And there could be any number of things that are at play in a case like this, which could be you've got a part of the population of these animals that has habituated and become accustomed to it and is willing to tolerate it, and you've got another part of the population that is more sensitive to it and you're simply not seeing them. The other fact is what you don't see around this road are the large carnivores which feed on these animals. These animals are spending a lot of their lifetime trying to avoid those animals that want to eat them, and so they may well have figured out this cause and relationship between, hey, if I'm around this road and those other bigger animals that want to eat me aren't, well, this is a pretty safe place to be. I guess I'd rather be around this stress than that stress. Next slide, please. So black bears. This is an animal that we have in Vermont, needless to say, and looked at one study that examined the effect of sound on bear use and access to habitat in South Carolina near a military installation. And it was looking at the sound effects from the discharge of ordnance. And what they found was that there was a displacement effect up to about 50 meters with bears. In Vermont, we've completed a study about black bear behavior in relation to ski resort development, 12 years ago maybe. This was at the Stratton Mountain Ski Resort, and we had bears that were collared with radio telemetry collars, and we were monitoring their movements and use of habitat over the course of, I can't remember now, 5, 6, 7 years. It was a long time. And the results from that study were very clear. They avoided the activities around the ski resort. And that's not to say that you won't see a bear crossing a ski trail from time to time. That certainly happens. But by and large, their behavior, their tendency was to avoid being around the developed areas of the ski resort, including the ski terrain, even during the summertime. In fact, where you had beach habitat within the islands of the ski terrain that was still producing nuts, the bears don't use it. They avoid it altogether, even though it's providing food source. Next slide, please. Another study, this one was intriguing because it was looking specifically at the effect of sound from wind turbines. This was out at the Altamont Pass Wind Project in California, and it was looking at the effect of wind turbine sound on California ground squirrels. And this is a species kind of like birds. They're very vocal. They live in communities, kind of like marmots out west. They live in these underground communities, and one of the things that they deal with every day is predator avoidance, because there's lots of raptors and badgers that want to eat them. So the way they avoid predators is by communicating vocally within the community. And what this study was doing is looking at, they had a control site and a wind site. And so there's some assumptions being made that it's the sound from the wind turbines that's having the effect. But what they observed was that the squirrels that were using the habitat around the wind project spent a significantly greater degree of time on high alert. They were spending more time looking for the presence of predators, and when there was communication, interspecific communication going on amongst the squirrels within the community, the thought was, because there is this other sound interference in the area, that they had to respond more quickly to the potential risk of predation. And so they spent more time on alert, and they spent more time running to the burrows and being underground than the squirrels in the communities that were not around the wind project. Next slide, please. So I know there's been a lot of concern expressed about infrasound from wind projects, and we looked at the scientific literature regarding infrasound and wildlife, and there really isn't a lot. There's some interesting information about the great variability in hearing frequencies of the myriad of animals around the world. Elephants, for instance, apparently have ear morphology that is designed to deal with very low frequency sound, and in fact they apparently communicate in ways that are not audible to the human ear, but that are very important to their social communication. The group of birds, they're galliforms, but it's basically the chicken-like birds. So in this case, the ruffed grouse, which is a common forest bird in Vermont, pheasants is another type of galliform. They have ear morphology that is similarly designed to hear at very low frequencies. So perhaps there's something to consider there. But I guess the take-home message here is we really don't know much about the effects of infrasound on wildlife. The next slide, please. Wanted to say a few things about bats, and my colleague, Mr. Darling, would be far better suited than I to speak to this one. I'll give it a shot. I know there has been some concern about whether or not sound emitted from the wind turbines is actually acting as an attractant for bats that's facilitating the collision problems with bats. And apparently the recent research has refuted that. It really isn't attracting them. Next slide, please. So just to wrap up, I'll go back to my earlier comments at the beginning of this discussion. I think in considering the science recently in preparation for this presentation and the discussion, I think we're intrigued, and there's more to consider here than I think we may have realized initially. And I think the problem, the challenge for us is that there's a real lack of science and information to guide us on this. So one of the take-home messages is we really need to learn more about how wildlife are affected by sound or noise from all sorts of sources, but in this case, wind energy facilities. But I would also underscore the fact that we know enough about the ecology of all these animals that we're charged with representing to know that it's really the amalgamation of all of these factors that's at the heart of the agency's concerns. You know, it's not just sound. It's the loss of the habitat, it's the fragmentation of the habitat, it's the change to the hydrology of the landscape, it's the introduction of invasive plants in communities that they didn't exist in previously. It's all of these factors taken in concert that is the larger concern for us. That's what I have. Thank you.
Thank you. Appreciate it. I appreciate everyone's comments.